Hello, hello. Hope you can hear me okay. Just hope. So we discuss data science, data engineering on this channel, mainly run by Biomedical, but any other data types are welcome as well. Let me just... So we normally go through the same routine where we check if the stream is working at all. Then we normally post about it on LinkedIn. Then we go through bodycares.com, see that everything, all the web apps and tools are working okay. So we check the stream, seem to be working okay. If no one joins in, we might just pop in some background music just so that we are not too bored. Make it not too loud. How do I do that? It's coming through. Just make it a bit louder. So my thing is about minus 5 dB and the music is minus 30 or so. So I don't know if that should be alright, but let me know otherwise, if otherwise. So as you notice, there's sometimes silly ads on bodycares.com now. Actually looking at it in our browser, I'm not sure if I'm allowed to show them on in videos. I mean, it's not monetized, but anyhow, there's nothing to report to because they're not really relevant. And a couple times saw some relevant ads and now they're really silly. So I don't know what's up with that. Yeah, there's something on biotherapeutics, just vaguely relevant, but mostly there's some rubbish. Unfortunately, hopefully they will improve. There's like a hearing clinic. That's hearing aids. Probably shouldn't mention the name, but that's a more relevant ad. It's good to see. Yeah, hopefully that will be more relevant, more useful. Here I'm on the same site in Firefox, and I'm using an ad blocker, so I don't see any ads. I'm not sure why it's showing me the ads, considering it knows I'm on the same IP address. So I had this bunch of tool. This one obviously could use some restructuring, especially those bits here that ideally will be somewhere on the left. The problem is when you have it on the phone, which is about this size window, then they all get scrambled up. So first we'll just check if they are working okay. Just a regular test. Should automate this. Obviously, should be unit testing. So you go one by one. Pretty sure I changed the default values for those. That's wait, maybe I didn't publish it. Just try to this one must have not published it yet. The ECG generator should look like should look like this, like a more realistic signal on power up on startup. When did I? It was 2 days ago. Just double check. We have to make sure. The web config is there, because this web config is also. Why is it unable to edit it? I don't know. Anyway, that web config is also now redirecting the website. If you access it via regular HTTP, it will redirect you to HTTPS and make it secure, which is awesome. Which is great. Anyway, back to this. I was saying we checking that everything is working on biomedical.com, and I did change this to look more realistic. This is the ECG signal generator. On loading, this default values should be different. So it looks more like this. I probably haven't published it yet. I might just publish it at the end of the stream. Those should be the new default values. So the white noise there and the 50 Hz noise is not 0 anymore. Just a very small value. 0.01. Right, and we're also making adjustments for this tools, web apps, to look better on a smaller screen. So when it's loading it on the phone, we would like it to work properly. Let me know if you can hear me okay at all, or if the music is too loud. I can happy to turn it off. Can also put up Zoom chat if you wanna just go online and have a chat. Create like unit tests for all of this stuff. There should be variability in the distance of these peaks, but it doesn't seem to work. They seem to be staying in the same location. That's odd, but it's this BMP noise. Is this number not large enough or something? So you don't actually see the difference. Just make it go to up to 100 just to see what's going on. So in theory, you would expect these peaks to change position in a random fashion. Right, yeah, they do. So the number's just not high enough. So what's a good number there? That's too much variability, isn't it? I'll probably leave it, leave it 100 for like the extreme case. Yeah, flood noise that maximum one should be okay because it's almost flooding the entire signal. Same for 50 hertz. This is goes 0 to 1. Yeah, with 1 flooding the whole thing. So the dynamic range of this is okay. And this BMP, for you to actually see some meaningful change, the default value probably should be around 50 or so. Yeah, so place default at 50. Save this. We'll publish the thing at the end of the stream. So currently, this is essentially the previous version of it. And ideally, you want to optimize it for a mobile phone, so a smaller screen. So this is what I'm originally optimized it for. Yeah, I have this weird screen. It's very narrow and long. Meant to be 4K, but it's actually only 2K because of the aspect ratio. It's not 16:9. Anyhow, but I think if it looks okay on a smaller screen size, then it should be fine on a bigger screen as well. The problem on a smaller screen is that if I have too many of these variables here, then you don't see the graph. You need to scroll down for it. Ideally, so one option would be just put it on the top and have all the variables at the bottom. kind of makes sense as well. Need more description in there. Yeah, the description probably can go. Can it go to the bottom? I don't know. Because that's also important for the SEO, the search engine optimization thing. I'm not sure what is it picking up, the the Google and Bing crawlers. You eventually want ChatGPT to say to get familiar with the site, be aware of it. This is the back end of the front end. This is the source code for the front end. It's just an API call, essentially. So essentially this says refresh, do an API call to the original server, which is, by the way, also on biomedical.com. It's also available via regular HTTP and now HTTPS via this different port. So you can make that API call yourself. If you don't like my user interface, you can just pull the original data and make your own GUI user interface. But so far, yeah, really tempting to switch those around. How do I do it properly? Make it smaller for the sec. Because the other thing is, important thing is it is resizing. So when you open it on a smaller screen, it will resize automatically. And then the question is, what's the minimum width and height that should be? In this case, yeah, so those are not resizing, which is a bit odd. You could probably resize them as well. What happens if you... work? Oops. Which another one of... Pretty sure it depends on the size of this bloody screen. Right. Right. So this all this hard sales on LinkedIn. Does your business sell internationally yet, or just at home? Like, yeah. Not actually selling anything, so it's hard to answer that question. On the mobile, it will also be nice if those vertical. Oh. It should have like different designs depending on if you open it vertically or horizontally. But I'm pretty sure it's worthwhile just switching places like that. Just see how it looks like. This in different browsers, just executed locally. Actually, know what in developer tools should be able to switch to mobile. And what's the standard? What's the standard mobile screen? I don't know. Why this is not the line? I don't know. Right, because it will do this funny business. Should those scale as well? I don't know. It will be messy, wouldn't it? Anyway, I can be doing this forever. Someone was also asking about the 1/f noise. It's also called fractal noise. The signal processed with frequency spectrum such that the power spectral density power per frequency interval is inversely proportional to the frequency of the signal. Something to do with pink noise, where each octave interval halving or doubling in frequency. Okay. The pink noise sounds like a waterfall. Well, how does a waterfall sound? It's often used to tune loudspeaker system, professional audio. Pink noise is one of the most commonly observed signals in biological systems. Okay. Understand the need to remove. Yeah, there's a audio of it. Okay, how do you generate it? We could have a generator. Just checking it on essentially all displays. Mine is 16 on by 9. It's my other display. In whichever way it will look like on mobile. I have to check it on mobile later. But yes, these things make a lot of difference in terms of how the signal looks like. You know, the window size, your screen size. Let me know if the music is too loud or something. I can turn it down a notch. So I'm just testing this thing. It will be an update of what's currently on biochaos.com ECG generator. So we'll eventually add more description to it, but also I was trying to optimize it to look better on a smaller screen size. So obviously this is not ideal. So I made it so the signal will show up first. Yeah, so I was just saying how important it is for when processing biomedical signals, is that like the size of the window, the size of your screen, things like that make a lot of difference. Oh, and also main thing, this noise, it's the time series, the x-axis noise this number wasn't going high enough. Well, now it's really hard to test, is it? Because we have 10 seconds. Yeah, this will be the variability of the distance between the QRS peaks, or the R peaks, whatever you call them. And yeah, that high number is probably too high. Yeah, well, that's an extreme case. Yeah, it meant to look as close as possible to like the original thing. Well, assuming normal ECG, but yes, this noise almost makes it look obviously like an abnormal ECG, because it's essentially skipping beats. That was kind of unintentional. Yeah, someone was asking how in EEG, how do you know that your synthetic signal looks like the original signal, like real EEG? Well, then I guess it all depends on what exactly you're trying to simulate. Because yes, if you have your epilepsy, it's essentially abnormal EEG. So essentially, if your synthetic signal generator misbehaves, then it becomes potentially closer to abnormal something. Just one way to look at it. So you don't have to over engineer anything. So in this case, when essentially I stuff something up, I don't make this number go too high, and then it starts looking like a abnormal, well, ECG in this case. They can do the same thing with EEG, I would imagine. Just trying to make it look a bit better on a smaller screen. The change of this default size width, and mainly when you resize the window, what's the absolute minimum width and height to which this each item will go to. And yes, it seems like just a minor cosmetic thing, but yeah, when reviewing the signals, it actually makes a lot of difference. Actually, a lot of commercial software was designed based on the look and feel of the original EEG for EEG to look like the original EEG review tools with the paper and the needle jumping around. So like the size, the paper A4, whatever, things like that. The ratio of the paper and how fast it's refreshing will be all modeling the original analog devices used to record the signal. Anyhow, I think this does look better. This is what it will show. I changed the default values as well, so it will on the get-go look a bit more realistic with a bit of white and 50 Hz noise in there, but not too much, so you can still see the P wave, the T wave, and yes, you can select your abnormal ECG as well. This is what the original recording looks like. So essentially in hyperkalemia, I understand is that there is no P wave visible. and then atrial tachycardia. There's an elevated T wave. You can see it in there. And yeah, once you increase this noise, this will be another one where you have skipped bits, and that will, my understanding, will highly depend on, again, your window size and how many of those been missing, and so on and so forth. Will be another abnormal type of ECG. Fix my camera. Doesn't work. OBS also has filters, but no specific background removal, which is unfortunate. I would have stopped using NVIDIA Broadcast altogether. There was also like an NVIDIA Studio driver update, and it's like 700 megabytes for nothing. Definitely do not need it. Anyway, back to our site. So that signal generator would have also changed the how it looks and feels. Probably would have put this window size on the top or bottom. I wanna test my own sound. Yeah, it's sounding okay. And it shouldn't be going into the stream. Just double check. Shouldn't be going into the stream. What's the delay like? No, it sounds okay. Can monitor my. This is when I'm monitoring my own sound. It's a bit annoying. There's like a micro, like 5 microseconds delayed or something. I can monitor the music as well, can I? 1, 2. It's hard to tell which one is which. Just turn it off. So yeah, I was reading more about that pink noise, and I don't know if I should add it as an option. Say in here you could have white noise, your 50 Hz noise. It should be 60 Hz as well. There should be like a switch here between 50 and 60 Hz, but then also pink noise, which just find out if we have an example of it. Pink, anything? Nope. Pink noise. There's this example, not entirely sure what it does. It's just 60 Hertz. Just removing the 60 Hertz component, is it? Yeah, it must be. Yeah, 60 hertz notch filter. Yeah, yeah, that's fine. It's yeah, the thing about the 50-60 hertz, like mains noise, is that if the electrodes are low enough impedance, you shouldn't have it to begin with. So if you see something like that, it's probably due to the fact that the electrodes are not attached correctly. So probably will need to be reapplied. If you have that much mains hum in it. So normally it's not a problem. But again, let me know if you want to see something similar as a web application that you can play with. But I'll ignore it for now because it's normally not a big issue. And the other thing, yeah, noise cancellation. Nice sound, okay. Yeah, it should be coming through. And no. Right, so here's an inverse F noise type. Periodic. In white. Look like white. Right, that's just the noise itself. Noise amplitude. And uniform. Power spectrum density. A logarithmic scale. This is a nice example. So Gaussian uniform. Periodic. Right. This is a good one. In white. It's a nice example, nice and clear. Don't like the. Can you stop auto scaling there? Just to see. Ooh. Right. Right. So I found if the LinkedIn friend, he was asking, do you have any experience removing the a 1 over f inverse f noise from EEG signals. So that's what's all right. So I need to address it in two-way. Break down the question. Well, first, what is inverse f noise? So it's a good example of we can check the differences between different types of noise, the raw waveform and its power spectral density. Just handy. They're all the same. Right. So we know what the we know what it is now. So we know what inverse F looks like, and then the out question is like, how do you remove it from your EEG signal? Well, one question to ask is how much of it there is in EEG signal, and why do we have to remove it? As in, especially like when cleaning, why do we have to target this inverse F? So say when we go and review, well, first thing, what is 50 hertz will be going up to here. Is it this shape that needs to be removed? Like you want to like flatten the response or something? It's not always happening. Again, how you render the signal makes a lot of difference. But yeah, I assume, say in this case, there will be, the argument would be that there is more of this type of noise, because is this what defines it, this shape of the FFT? This is not an actual FFT, it's a PSD. But suspect it will, yes, and it's logarithmic scale as well. Don't necessarily like logarithmic scales for no particular reason. So the question is, how do I measure how much inverse F noise do I have in this signal? And why not target like Gaussian or uniform white? Like why remove specifically inverse F noise? This would be an interesting question, but not sure how to address it. If anyone has any suggestions, you're more than welcome. But that being said, this tool looks very interesting because you can see what the different types of noise look like. This would be your uniform, Gaussian, periodic, and inverse. Yeah, which does look more like yeah, looks like EEG, more like EEG. So yes, it's a good question of like how much EEG you actually have in there. Well, first, these electrodes are sitting just on top of the brain, so it's the proximity to the target neurons that you're trying to record from. So even if you see something like that in it, like, yeah, why would you filter it out assuming that is the EEG? And yes, something like this would imagine will highly depend on your window size. So yes, potentially as soon as you make the window size larger, you have it seems to be that you have more of this inverse F noise. Samples, make it 6. Yeah, I don't know. Let me know if you can hear me at all, or if the music is too loud. Meant to be background music. I have my voice going up to minus 10 dB and the music is about minus 30 dB. So I attenuated quite a bit. But what I hear in my headphones is not necessarily what you hear. Even if I turn this monitoring, I'm still not sure it's the same as what's going into the stream. Please do let me know. You can also say hello. Anyway, these streams are all right. I gotta get a get rid of all notifications on my phone. So I'm thinking adding this as turning this into a web application, obviously improving the way it looks and feels. Meant to be 1000. What? Sweet. Yeah. Anyway, yeah, and then potentially later we could also add it here, so you have an option adding a white noise your main sum, which by the way should be an option between selecting 50 Hz and 60 Hz. But then you could just have a drop down menu like this for which type of noise you want to add on top of the signal. And yes, out of these 4, the inverse F really looks like baseline EEG. Anyway, what else do we have? Just keep going. We have this tool here, which I haven't updated in a while, but I'm pretty much happy with how it looks and feels. It's responsive. Oops. It's how does it look like on a smaller screen? Kind of okay. Yeah, I mean, ideally we'll see all this in one. You can change the size of your things. Yeah, maybe if it look like that is not too bad. Some things are getting scaled by the browser itself, and some I can set the scaling myself. Coherence. So in this case, this would be the default size, and then when the screen gets smaller, when essentially this size doesn't fit anymore, then we'll start making it smaller, and this will be the minimum width and minimum height. That means just testing it in another browser. This 100% will be the default. So how does it look like a mobile phone screen? Yeah, this probably should look, yes, something like this. This is, I think, the size I recorded one of the videos in. One of the shorts videos, because it has to be vertical orientation, because people mostly watch it on the phone. Please let me know if you had a look at biomedical.com and would like to make any comments or would like to see anything added to it, removed or changed. This is a good time. It's all a beta work in progress. And apologies if you see any ads on it. They're just there for me to cover the electricity cost of running the server, pretty much. It's a not for profit endeavor. It's also secure, so you can access it from anywhere. A university campus at RMIT. When I tried it, it was blocking the site, so it shouldn't be blocking it anymore. There's also a section, this has to be updated. Might do it offline. And yes, this is an important message. Any military use of this site is prohibited. You never know how much imagination there is out there. They'll find a way to use anything for causing harm to people. Yeah, keep updating this bit. You have a lot of resources there, so some of those need to be updated as well. By the way, I have one of those if you're interested to see me recording my own EEG or ECG. It can definitely be done. It's a 16-bit analog to digital converter. Don't know what that means. I was recording using differential analog input, 8 different. So yes, I can record up to 8 differential channels, 16 single-ended. Yeah, this is a good debate regards. So EEG is normally recorded using single-ended. So you have your one reference, and so essentially it's the voltage potential between a reference to each electrode, and then differential pairs, you record the voltage potential between two electrodes. So it's like the ever never-ending debate which one's better and how one compares to the other. We can try, so using this device we can actually try switching between single and that. So you can have 16 channel or 8 channel. Of the 8 channel will be more localized, whereas the 16 channels will be between each point on the head to a general reference, to one reference, which will be further away. So it could be a nice experiment which we can do. We could even do it live. In the past, I was just using one differential pair. And this gel-based commercial clinical grade electrodes. It's a good common mode rejection ratio of 100 dB. It's pretty impressive. It's pretty high. Impedance above 10 gigaohm. 500 picofarad. So yes, this could be an issue. So generally want this to be as high as possible. In reality, this could have an effect. So there will be ideal numbers for recording different types of signal. And by the way, as a side note, isn't ECG normally being recorded with like 9 leads? 12. I think it's 9 electrodes. A question is, which I don't know, well, it's either 9 or 12 or whatever. That's less important. We can do both. The question is, where is the reference electrode located? And is there only one reference or more than one? So with EEG, you normally have 2 references on both sides of the head, so like behind the ear somewhere. Anyway, I would want to add this as a next step. It's a nice and simple example. We don't want to over complicate things. Yeah, the naming here is a bit messy in my project, but probably have to leave it as is. If someone tries to redeploy it elsewhere later, they can obviously change the names. By the way, all of this is open source and released under Creative Commons. So anything you see, you can reuse, ideally with attribution. Just mention the source, mention where you got it from. Yeah, Creative Commons attribution license. You can just knock yourself out. As I mentioned, the APIs are also available, but currently, let me know if I need to provide you better documentation. So, say someone wanted to implement this in Python or something. I don't know if they want to use, do everything from scratch or use some of this. If they do, they can just, in this case, for example, use an API. Let's see what else we've got. Yeah, the statistical analysis thing has to be probably broken down into separate parts, made more simple. The idea here is that you have this different. Yeah, I don't know what's over engineered about it. It's this bit. Yeah, it's a very large. What's it called? Those. There's a name that they use for these things. Fancy name that I never use. I have it written somewhere to remind myself to use the keyword. A dashboard. A dashboard. Let's call this a dashboard. What does it even mean? Toolkit. Yeah, but then toolkit is also not a great name, is it? Yeah, it's actually resizing pretty well, but then still the whole thing doesn't fit into the one screen. So that's unfortunate. By the way, let me, if someone is listening, let me know if you can hear me at all, or if you want to ask a question, have a chat. We can also arrange for you to go live with me on Zoom. But instead of my consider my camera is not working, might as well bring back the topics. How about we do? No, shouldn't be called logo, right? Is it? Should be renamed to rename logo merge. Then we have logo left. And this is the topics I was talking about and probably have to be updated. And okay, how about we move those topics to the right. Keep the left logo on. And those topics. Ooh, why is it so large? Oh, or is it the whole thing? Yeah, it's many biomedical data analysis, many EEG and ECG that is correct, but any other data types are more than welcome as well. So we're normally doing the web apps on biomedical.com, we're testing and updating them. We did solve the SSL issue, so the website should be now secure. Yeah, we don't particularly want to talk about NVIDIA broadcast, OBS or DaVinci Resolve. So this can go. Does it look like it's stretching the thing? Um, I'm just checking how does it look like. Sometimes on my phone, I don't know why, it's a reduced picture quality. I ask it to increase the picture quality, but it doesn't really do that. Why not? Right, so talking BS Biomedical. Biomedical, yes. Web apps, yes. That's an update. Biomedical data review. Yeah. The other thing. Yeah, that's right. We have the Tempadica E4 Tempadica. So that the E4 wristband. So I can, well, I assume I don't have epilepsy, even though I'm not sure. But then, so I have recordings that I made of myself using that watch. Yeah, it's a bit finicky. I can show it to you. You can Google it as well. I don't know if it's a commercially sensitive thing to show. It's a bit finicky in terms of it has to be really tight on the wrist. It's actually very uncomfortable when it's tight on the wrist, but it has to be tight for the signal to be there. So if it's not tight enough, it would not even show the PPG. So the PPG signal will be of a lower quality, and so you have to tighten the wristband, but then it becomes super uncomfortable. I had a video on it on the YouTube channel. Hooray, we have 70 subscribers now. But ideally, I'm not sure why all the 721 followers on LinkedIn would not subscribe to my YouTube channel. That's a mystery. I guess it's really hard to move people to another platform. But if you know of any other reasons, please do let me know. We had this old video about this loading Empathica stuff. By the way, how about we check what the status of that competition? There meant to be results on it. I would guess. I have a link to it. Maybe not. Surely should have it somewhere. When the data was originally posted, is Eval AI just using AWS Eval AI? What's this website? Right, this one here. It was hard to find. If that competition, all challenges. Maybe we should find something better. Or another data set that we could use. Quite a lot of stuff. Not sure why there's like no description of what it is. It's Mayo Clinic. The competition ends in 2099. That's nice. That will give you enough time. The, the logo of it should be familiar. This search engine here. Epidemic. It's epidemic, not epileptic. Seizure. Right. It's eBay machine learning challenge. So just for comparison's sake, we open. Does this one have a leaderboard? It does. Does this competition has a leaderboard? It does not. So this is what a leaderboard should look like. You can see all the results are pretty much saturated. I don't know what the competition was. Interestingly enough, it ended at 10 a.m. April 2nd. There's no leaderboard. Yes, it definitely should be made public. That's the whole idea of public competition. Yeah, we'll have to know if we should get back to this. So probably not. It's by Mayo Clinic something. No. Your realistic musculoskeletal hand to solve dexterous manipulation tasks. Okay. What do I need to log in to see the website? I'm not sure what these multiple phases. Yeah, this is interesting because these numbers are not saturated. What the biometric? Okay. Uh, Familiar with this evaluation summary of all successes of H, whatever H is. To look into this, but do they publish the data set? Is that um, sounds like you need the Google login to even see the data sets. Just checking a few things. Let me know if there's any questions or if I can do anything differently on the site. Wait a sec. This should be 20. I think the default is 21. Put these two. Yeah, I think we're done for today. There's someone in the chat, but there's no messages. Yeah, you can type them, ask anything offline. I will address it in the next stream, which will probably be tomorrow. I'll see you tomorrow. Have a good one.